Today I'm going to explain two terms that you may have heard me mention quite a bit, but maybe didn't know exactly what they meant. They are particularly relevant when talking about diamonds, but absolutely helpful when talking about all gemstones in general. Today I'm going to explain exactly what we mean when we talk about refraction and dispersion. Both of these terms are referring to how gemstones interact with light, and this is so important because, of course, that's where gemstones really get their beauty from. If they weren't refracting or even reflecting light, we wouldn't be able to see how beautiful they really are. It all starts with the refraction process, and quite technically, this is essentially when light first enters a gemstone and it actually slows down and potentially even changes direction. So this is really what we mean when we say light is being refracted. That's the technical process that we're referring to. So why does this happen in the first place? It's because the atoms that are in the gemstone are generally more tightly arranged than the atoms in the air. So when the light changes from being in the air to being in the gemstone, it's going to slow down and potentially bounce around a little. When we talk about a gemstone's refractive index, this is exactly what we're measuring. Essentially, the higher the Ri of a gemstone, the more it is slowing down the light. And as you can learn all about in our Tools for Identifying Gemstones video, we are measuring that with our refractometer, which is arguably the most important tool that a gemologist uses to identify gemstones, period. You've probably also heard me talk about gemstones that are doubly refractive, and in fact, most gemstones actually are, but some are just more dramatically doubly refractive than others. This occurs when light enters the gemstone and it actually splits into two different rays. So when something is doing this very dramatically, we can actually see it with our own eye without any extra tools. So good examples of this are peridot and moissanite, for example, and they display what we call doubling. So when we look at that gemstone, and yes, sometimes it helps to have a magnifying glass or a microscope, of course, and we look at the facet edges of the gemstone, we can actually see them doubled, and they are actually mirroring each other. With moissanite, I've said this many times, it is the greatest tell that it's not a diamond or a cubic zirconia. It has very strong doubling. Another well-known effect of being doubly refractive is when a gemstone will then show pleochroism, and this is when we can see two different colors depending on the angle that we view the gemstone at. So very famously, tourmaline and tanzanite are both very strongly pleochroic, and we tend to see multiple different colors, sometimes shades of different hues when we're looking face up at that gemstone. And as I mentioned, the more a gemstone slows light down, that means that the atoms are very tightly packed together. And quite famously, diamond is made out of 100% carbon, but the difference between a diamond and straight pencil lead, which is also 100% carbon, is that the carbon atoms are so tightly packed together, it makes it the hardest material on Earth. So because those atoms are so tightly packed together, it is really slowing the light down when it enters the gemstone, which gives it a very high refractive index, and that's how we get such a sparkly gemstone such as diamond. Other gems that have also very high RIs and are known for being very sparkly are zircon, cubic zirconia, moissanite, and even garnet. So where does the sparkle come from? This is essentially where dispersion enters the chat. Basically, when white light again is entering the gemstone and it slows down so much it can even split into spectral rainbow colors. So of course, this is what you're seeing when you look at a very sparkly moissanite or diamond, and you're seeing those rainbow flashes that make it so attractive and beautiful to your eye. This is exactly what's happening. These gems are slowing down that light so much, the white light that is entering the gem is actually being refracted and then reflected back to your eye as rainbow colors. Dispersion is exactly this process, and in fact, when we see those rainbow colors, that is also what we refer to as fire. So when you are shopping for diamonds, you'll probably hear this a lot. You want a very fiery diamond. That's a diamond that's going to be very sparkly and showing you all those different rainbow colors, which makes it just so attractive. Diamonds are what they are, as well as moissanite and cubic zirconia, because of course, a colorless gemstone is going to make seeing dispersion and the resulting fire very easy to see. It's then high contrast, you can really see those rainbow colors. But there are actually a very select group of color gemstones that also have very high fire. And we don't talk about them a lot because a lot of them aren't very well known. But of course, they're very special because you are getting the best of both worlds. You're getting that saturated body color with those fiery spectral colors. It makes it a little bit harder to see, but they are very unique and very special. These include colored zircon, such as blue zircon, of course, or even yellow and brown, demantoid garnet, which has that beautiful saturated green color like an emerald, and a little known gemstone that we call sphene. And I will be doing a video on this because it is very special and very unique. Thank you so much for watching, and if you do want to learn more about the refractive index and how to measure it with the refractometer, definitely check out our video on tools for identifying gemstones.